Here we have a circuit with a voltage source and a current source. What we do in superposition theorem is we take this circuit and divide it into two parts. Like in one part of this, we remove the voltage source and do the short circuit. When we remove the voltage source, it's going to become a short circuit. Short circuit is like straight line. And when we remove the current source, it's going to become an open circuit. So we are going to have an open circuit like this. So it's going to be removed right here. There's no current flow. Now let's actually do that. Let's divide this one into two. So this one, if I apply superposition theorem, it's going to look like this. Here we are going to have the circuit. This one, first I'm removing the voltage source, so it's going to be no voltage right here, and the others remains the same. Let's label the other things. Here we have resistance, the current source. Okay. This is a 5 ohm resistance, and then 12 ohm resistance, 4 ohm resistance, 2 ohm resistance, and then 5 ampere current. 12 ohm, and then this is 4 ohm, and this one is 5 ohm. I remove this 60 voltage battery, so this is going to be just a short circuit like this. Okay, now from this one, what we can do, we can find the voltage across this resistor by combining them together, or I can find out the current also, like the total current passing through the system. So to do that, what I'm going to do is I'm going to combine all the resistors into one and make it only two resistors, or one resistor, one equivalent resistor. Let's see if I can do that. So first I'm taking this 4 and 5, these two are in parallel. So when we have resistors in parallel, we can find the equivalent resistor here. Let's call this an equivalent 1 for this one, 4 and 5. To find this one, product over sum, 4 times 5 divided by 4 plus 5. So this is going to be 20 divided by 9. Okay, this is equivalent resistor for this one. So if I draw the new circuit, okay, this is, like this is one circuit. I divide this one, I remove the voltage source, but this is going to be addition of another circuit that's going to look like this. Okay, in that one we will have a voltage source, and resistors remain the same, only the current source is going to be removed, and the current source removed is going to be open circuit. It'll look like this. Okay, 5 ohm resistor, and this voltage remains the same, that's 60 voltage, and then the 12 ohm resistor remains here, and then 4 ohm resistor here, and then 2 ohm resistor here. And if I remove the current source, that's going to be just an open circuit like this. Okay, and when you combine these two, you will get this circuit back. That's the idea. So if you want to find out currents, what you have to do is you have to find out current here, and then add them together at the end. Then only you will get the answer for the current flowing through this original circuit. Okay, so here I'm dealing with this circuit. Let's see what we can find from this circuit. So I'm going to apply this. I'm going to combine all these resistors together and see what we can find. So I combine these two. I combine this 5 ohm and 4 ohm resistor, and I got 20 over 9. And then what I can do is here you can see this 20 ohm resistor and 12 ohm resistor. Once you combine, these two are going to be on series. So when you have resistance in series, we can add them together. So the R equivalent to is going to be 20 over 9 plus 12 ohm resistor. Okay, now we have this one. This is the new equivalent resistor right here, and this one 2 ohm, and these two are going to be in parallel. And if you, for the parallel, again you have to add them. Like, let's try to simplify this one. Let's see what we get here. Let me divide 20 by 9. 20 divided by 9, that is 2.22. So I'm going to get it here, 2.22 plus 12, that is 14.22 right here. And then after that, we do the product over sum again for this one, 2 and 14.22. R equivalent 3 is equal to 14.22 times 2 divided by 14.22 plus 2. That's going to be 16.22. So 14.22 times 2 divided by 14.22 plus 2, you're going to get the resistance value 8.333 repeating, 3 repeating, or you can put 8.3 repeating like this. Let me double check with my calculator. 14.22 times 2, I get 28.44, and if I divide that one by 16.22, wait a minute, let me double check. So here I combine this 5 for resistor, that is product over sum, 4 times 5 divided by 4 plus 5, that's 20 over 9. Let's actually see what's value I get for this. 20 over 9, 2.22. Okay, 2.22. If the equivalent resistor for this one is 2.22, then this is going to be series with this. So 2.22 plus 12, that is 14.22. That's okay. And then here we have 2 ohm resistance. Oh, okay. You know what? I had a problem with 8 ohm resistance. That's why I got 8.3. Let's do this 8 ohm resistance. If I do 8 ohm resistance, this 14.22 times 8, 14.22 plus 8. So this one and this one also 8 here. Let me double check. 14.22 times 8. Divided by 22.22. 22.22. What I'm doing wrong? 5 times for 20. Product over sum, 5 times for 20. 20 divided by 4 plus 5, that's 20 over 9. Okay. Okay, so you know what? Yeah, I messed it up. Let me redo. Let me deal with this circuit first. And then go back. So here we have voltage, and this is the one is easier, so because we can find out the current from this. So here we have 8 and 12 in parallel. So the equivalent resistor for this one, the first one, if I combine them together, that's going to be 8 times 12 divided by 8 plus 12. That's product of sum. 8 times 12 divided by 8 plus 12, that's 20. 12 times 8. 8 times 10 is 80. 8 times 2 is 16. So this 96 divided by 20. 96 divided by 20 is equivalent to 48 divided by 10, so 4.8 ohm resistance. So the equivalent for this one is 4.8. Then once you find the equivalent, that equivalent is parallel to this 4. So R equivalent to is 4.8 ohm resistance, and again do the product of sum with 4. 4.8 times 4 divided by 4 plus 4.8, 4 plus 4.8 is 8.8. Let me calculate that. 4.8 times 4 divided by 8.8, that is 2.18. Okay. 2.18 is equivalent to, so that's going to be right here, and then that is in series with this 5 plus 2.18, that's 7.18. Let me double check. 12 times 8 divided by 12 plus 8, that's 20. 8 times 12 is 96 divided by 20, that is 4.8. 96, 48 times 2, 96. Yes, so that's gonna work. And after that, what I did product over sum again, because these two are parallel. Yeah, 4.8, this is 4.8 times 4, that is oh okay, now I'm seeing the mistake. Okay, you see, this is an open circuit, right? There's no, it's not in parallel actually, this is in series. These two are like, I can directly add them. My mistake, sorry guys. So this is R equivalent 1. These two are in series actually, because if I remove this current source, this is no longer parallel anymore, so this is in series. You can actually delete this wire right here, it's going to be the same thing. So this is 12 plus 8, that is 20 ohm resistance. The first equivalent resistance is 20 ohm resistance, and then this 20 ohm resistance is parallel with 4, that's R equivalent 2. So that's going to be 20 times 4 divided by 20 plus 4. 20 times 4 divided by 20 plus 4, that is 80 divided by 24. Okay, let me calculate that. 80 divided by 24, that is 3.33. So now it makes sense. 3.33 ohm resistance, and then here after I combine them together, this is again series with this 5 ohm resistance. So this is going to be R equivalent 3. That's going to be 5 plus 3.33, that is going to be 8.3 repeating. This is my equivalent resistance at this point. So I can redraw this circuit. Let me create a new page. Okay, in this, now I'm going to go ahead and redraw this circuit with one voltage source, that is 60 voltage, and then only one resistor. I combine all the resistors together and put it as one, that is 8.3, approximately 8.3 ohm resistance. And this one is 60 voltage remaining the same. Now I have the voltage and the resistance, I can find the current. Let's assume the current is going from this side to this side. Okay, this is 60 voltage, and if I assume this direction, the equation for the current is going to be, okay, let's say the current is Ix. Okay, let's label the current first. If I label the original circuit we had here, if I label the current going through this as Ix, then I have to label here as I prime X, because when we divide this one into 2, the current is going to be different. So this is going to be I prime X, and I'm going to label this one as I double prime X. Now what we are dealing with is I double prime X. So this one is I double prime X. I can find the I double prime X by using the Ohm's law here. P is equal to I times R. Therefore I is going to be equivalent to voltage divided by the resistance, and voltage across this circuit is 60 voltage. So I double prime of X is going to be equivalent to 60 voltage divided by 8.3. That is equivalent to 7.2 ampere. Okay, so now we found out the current. By finding out current, what else I can find? Let's look at this circuit. This is the circuit we are dealing with. So this circuit, I found out the current, that is I double prime X is equal to 7.2 ampere. So I know the current passing through this 5 ohm resistor is 7.2 ampere. So I can find out the voltage right here. This voltage, let's call this one V. Okay, let's, in the original one, I'm gonna call this voltage across here as VA. If I call this one VA right here, this is going to be V prime A, and this one is going to be V double prime A, because the voltage is going to be different when we divide them into two. So to find out the original voltage at the end, we can add these two together and combine them. So here, if I want to find out the V double prime A voltage, I can apply the Ohm's law. Ohm's law says V is equal to I times R. And if we have differences in voltage, here also you can see, like, as the current passes through this 5 ohm resistor, there's going to be a voltage drop. So this is not useful here, because we are not trying to find current or anything else. We just want to find out the voltage. So to find out the voltage, you can see logically, like, this is a plus sign right here, this is minus. When we have a plus on top, this at this point the voltage is going to be 60 voltage as well. So this node we are going to have 60 voltage, and then 60 volt current going from 60 voltage to this 5 ohm resistor, and when it passes through the resistor, there's going to be a voltage drop. So we are going to have a 60 minus, and now we apply the Ohm's law. Ohm's law says current voltage is equal to I times R, and the current passes through this one we already know, that is 7.2 ampere, and the resistor right here is 5. So if we subtract 7.2 times 5 from 60, that's going to be the voltage we are going to have right here. Okay, let's calculate this one. This is, if you calculate this, you're going to get 24 voltage. That is V double prime A. Okay, now we have the current through this, and we have the voltage right here, that is 24 voltage. If we know the voltage here, I can find out the current passing through this. Let's assume the current direction is this. Let's label the current name. So if I label the name of this current in the original circuit given as IY, here is going to be I prime of Y, and here is going to be I double prime Y. Okay, I can find the I double prime Y. I double prime Y is going to be equivalent to voltage divided by the resistance. Voltage is going to be voltage difference. Like here, the reference voltage is always 0. This is our reference voltage. This is connected to the ground, so this is going to be always 0. So this voltage minus 0 divided by the resistance. So we can just neglect the 0 and say I double prime of Y is equivalent to 24 minus 0. We don't have to write it. And then divided by the resistance between, that's 4. So this is going to be 4 times 6, that's 6 ampere current going through this. 6 ampere. Okay, if 6 ampere going through this, and we know that this one is 7.2 ampere. If 6 ampere going through this, then this must be 1.2 ampere, because according to Kirchhoff's current law, whatever the current going through a node should be the current exiting the node. So exiting the node. Here 7.2 ampere entering this node, and 6 ampere going down. So the 1.2 ampere current should be going through this direction. So 1.2 ampere, this one. So if I say, if I call this one, what the name I can put? I can say IW. If this is IW in the original circuit, This is going to be IW prime right here, and this is IW double prime. So we found out IW double prime is equal to 1.2 ampere. IW double prime is equal to 1.2 ampere. Okay. So these things we can find from this circuit. Okay, now let's look at the other circuit. Let's look at the other circuit and see what I can find from this. Okay, looking at this, let's try to combine everything together and make it an equal, find an equivalent circuit for it. You know, the initially I was solving and finding the 14.2. That's actually helpful right here, because I should have solved, like, that was right. I was convincing this circuit with that, and that was actually correct. Let me redo it. Okay. Here we have the resistance, these two are in parallel, so the equivalent resistance is going to be product of sum. 5 times 4 divided by 5 plus 4, so 20 over 9. 20 over 9 is what? Let me calculate. 20 divided by 9 is 2.22. So we can say 2.2 repeating, and then R equivalent 2 is going to be, so once we have combined these two, so here we are going to have the 2.2 repeating right here, and these two are in series, so we can add them together. So the new equivalent circuit is going to be 12 plus 2.2 repeating, that's going to be 14.2 repeating. So once we have the two current right here, it's good enough, because we can actually find out the current passing through this, because if we can read through this circuit like this, we can put because once we combine these two are in parallel right now, these two are in parallel, and one of them is 14.2 ohm resistor and the other one is 8 ohm resistor, and the current passing through both of them is 5. Current going through this is 5 ampere current. That's the one provided right here. So from this one, what we can do is we can use current divider equation to find out the current passing through these circuits. So let's use the current divider equation. Current divider equation says that if you want to find out current through any resistance, let's say I want to find out the current through 8 ohm resistance, current divider equation says that's equal to source current, that is 5 ampere, times the other resistance. Like if you want to find out the current at 8 ohm resistance, you have to put the other resistance on top, that's 14.2 right here, and 14.2 divided by the addition of both of the resistance, that's equivalent to 22.2 ohm resistance. And once you calculate that, you're gonna get 3.2 ampere. 3.2 ampere. Okay, so that's the current passing through the 8 ohm resistance. But here we didn't label the name for the current passing through the 8 ohm resistance. We can put a new name, like let's say IA. If this is IA, this is going to be IA prime. We can call this one as IA prime, and whatever the current passing through this is IA double prime. Okay, so we found out IA prime, that is 3.2 ampere. If the current passing through 8 ohm resistance is 3.2 ampere, what's the current passing through this? You can apply KCL right here, because KCL says whatever the current entering through a node is equal to exiting through the node. So 3.2 ampere is gone right here, so the rest of the current has to be going through this. So that one is 5 minus 3.2, that is 1.8 ampere. So the 1.8 ampere current is passing through the 14.2 ohm resistance. Now I can see, if I redraw if I expand the circuit a little bit, I can see what's happened to what's happening to the 1.8 ampere resistance, because 8 ampere current, because I can apply current divider to see how much going through each resistor. Okay, let's do that. I'm going to expand the 14.2 coming from this 12 ohm and this. We added this 2.2 and 8 and made it a 12.2 and 2.2 and 12 into 14.2. What I'm going to do is I'm going to expand it back. Okay. Okay, so here let's take this point. Oh, I don't even need another diagram for it. I can look at the original circuit and say here we know that this IA. Wait a minute. Okay, in the original diagram, let's call this one IA, and this one is IA prime right here. And we know the IA prime, that is 3.2 ampere. This one is 3.2 ampere, and the current passing through this 12 ohm resistance, that's the one. 1.8 resistance, that's the one we found out right here from this KCL right here. So that one we called IW prime. That's actually in the opposite direction. So let me put in the opposite direction. I prime W, that is equivalent to 1.8 ampere in this circuit. So from this one we can solve for I prime Y and I prime X. So to find out what we do, we can use current divider. Okay, let's say I want to find out the I prime Y. What equation I have to use? Current divider. Current divider says source current, that is 1.8 ampere, and whatever the rest, if you want to find out the current here, I have to put the other one on top. So the other one is 5 ohm, and then addition of these two in the bottom, 5 plus 4, that is 9. Okay, 1.8 times 5 is 9. So the current passing through this one is 1 ampere, this one is 1 ampere current right here. Okay, and the direction is right. And here if the 1 ampere is going through this, and this one must be 0.8 ampere current, and the direction is this way, and this one is I prime X in this direction. Okay, now we have solved for all the currents right here. Finally, what we have to do is, like, once we find out current here and here, we have to just combine them together based on the directions. I made a lot of mess. Let me see if I find out something and solve for it. So let's start with IX. IX here in the direction of this opposite direction. So let's find out the IX. IX is equivalent to I prime of X, I prime of X plus I double prime of X. I prime of X is 0.8 ampere in this direction and 7.2 ampere in the opposite direction. So if I want to express in terms of, like, here, if you look at the original direction, we assume this direction, right? So if you want to express in terms of this, I had to put a negative for this 0.8 because this opposite direction of what we assumed. So I put a negative 0.8 for the I prime of X, and then I double prime of X is in this direction, that is positive 7.2. So positive 7.2 minus 0.8, we are going to get 6.4. Okay, 6.4 is the original current passing through this 5 ohm resistance. 7.2 minus 0.8, let me double check. 0.8, that is 6.4. Yes, so that's the current Ix. Let's look at the IW. IW prime we found out here, that's 1.8 ampere in this direction. That's again, that's opposite of the direction we assumed, so that's going to be negative. And what about this? In this circuit, did we find that? This is from this circuit. Yeah, we solve it for 1.2 ampere, and here it is 1.8 ampere in the opposite direction. 1.2 minus 1.8, that is negative 0.6. So IW is negative 0.6. So negative 0.6 is, our assumption is wrong. The current through this actually entering this node. Let's look at the IA. IA prime is what, 3.2, is in the same direction as we assumed. And let's look at this circuit. IA double prime, did we calculate for it? IA double prime we didn't calculate, but the thing is, here you can see this is 1.2 ampere. We don't have any other, this node is not going anywhere. So whatever the current entering this must be the current here. So the IA double prime here is 1.2 ampere as well. So it's in the same direction as this. So these two are going to add up. 1.2 ampere and then 3.2, that's going to be 4.4. So this one total current is 4.4, and that's basically it. And then if you want to find out the voltage here, I think we solved the voltage for this. Let me see. We solved the voltage VA double prime, but we didn't solve for this. We can solve for this simply by taking I prime Y. So here voltage is going to be what? The current through this is VA prime minus 0 divided by the resistance in between. VA prime minus 0 divided by the resistance in between, that's 4 ohm, that's equal to 1 ampere. Therefore VA prime is going to be equal to 4 voltage right here. So this is 4 voltage, and add with this one 4 plus 2.4, that is 6.4 voltage. So the original voltage is 6.4 voltage. And if you want to find out the voltage right here, you can do in 2 ways. Okay, this one is IA is 4.4 ampere. I know IA is equal to 4.4 ampere. So if I have the current here, then I can find out the voltage here by taking the Ohm's law. Oh, voltage difference, that is, let's call this one VB. Okay, VB minus 0 divided by the resistance in between should be equal to this current. So VB minus 0 divided by the resistance in between 2, that is equal to 4.4. Therefore VB is 2 times 4.4, so this is 8.8 ampere current, 8.8 voltage. Okay, that one is straightforward, and that's basically it. And if you want to do furthermore and find out all the current, you can do that too. And it makes sense right here. You can see this. Wait a minute. Yeah. Yeah, that's basically it. Like, that's it for the video. That's it for this video, because we just found out everything, right? And I hope you guys find this video helpful. Thanks for watching. See you guys on my next video.